Hello everyone. This question has been taken from Irodov Fundamental Equation of Dynamics question number 105. The question says a particle of mass m moves in a certain plane P due to a force F whose magnitude is constant and whose vector rotates in that plane with a constant angular velocity omega. Assuming the particle to be stationary at the moment t is equal to 0, find part A, its velocity as a function of time. B, the distance covered by the particle between two successive stops and the mean velocity over this time. Let us solve this question. You can go through the write-up, what all things are given and what to be found. We can assume that the particle was at origin at t is equal to 0 and the force was acting in the direction of x at that time, started acting, because this is the initial condition as per the question. This force is continuously rotating, though its magnitude is constant, but continuously rotating. Its vector means its direction is continuously rotating. So what is happening at t is equal to 0, force is in the x direction. As the time elapses, the force vector will keep on rotating, rotating, rotating. So the particle will take a path like this on which it will traverse. For studying the motion of the particle, we can consider at t is equal to t, the particle was at a position at position A. Since the force vector F is continuously rotating with an angular velocity omega, so force will all the time be in the tangential direction to the path of traverse of particle. So this is in the tangential direction at point A. And at A, we are considering that the particle is at the time t. So by that time, the force vector has rotated from 0 to omega t. So this angle is omega t. If we extend this, the same thing. Now we will apply the Newton's law of motion for the particle at point A. We will divide this force into horizontal and vertical component, that is Fx and Fy. So Fy conveniently we can write is equal to mass into acceleration, that is mass into dy by dt, dv by dt. Fy from the diagram we can make out easily that Fy is f sine theta, that is theta is nothing but omega t, so you can put over here. You will reach to this equation. Now at this location the particle was at time t, so we should assume that the velocity was, we can notate velocity in the y direction at this location as v subscript y. So when you integrate both sides, so you can write conveniently like this: dvy at t is equal to 0, the particle velocity was 0. At t is equal to t, the particle velocity was vy in the y direction, and integrate it. Upon integration, we got this equation 1, that is vy is equal to f by m omega into 1 minus cos omega t in bracket. Similarly, we will calculate for force in the x direction, and we will reach to equation 2. To obtain the absolute velocity at A, we know that V will be equal to Vx square plus Vy square under root. And since V is the magnitude, so it has to be all the time positive. So after putting the value of Vx and Vy from equation 1 and 2, we can come to this result, that 2f by m omega, and in modulus sine omega t by 2. Important to understand why it has been put under modulus, because V is a positive quantity. Sine can be positive or negative depending on the angle. So V is all the time positive. So we have to keep sine omega t by 2 inside the modulus to make all the time V as positive, because it's a magnitude. Absolute velocity at any instant, we know that it is the rate of change of displacement at that particular instant of time, so ds by dt. So we can fetch this equation V from equation 3 and write like this. Keep on proceeding. When we integrate ds from 0 to s and 0 to delta t time duration, we can write equation, we reach to this equation number 4. Now in the question it is being asked that what is the distance traversed between two successive stops. So initially the particle was stationary, means at t is equal to 0 the particle was stationary. So the next stage at which the particle will come back again to stops, the next successive, we know that when sine omega t by 2 will become 0, so at that time the particle will come to stop, because V is this. So sine omega t by 2 from 0 to pi angle will have some positive value, but 0 it was 0, and at pi it will again become 0. So we can say that next stop will be at omega delta t by 2 when it becomes pi. So delta t will be 2 pi by omega. So we got the value of delta t. Also for omega t by 2, when greater than 0 and less than pi, it should be pi. Sine omega t by 2 will always be 0. Therefore, equation 4 can be written as this, rewritten as this. Hence, the distance traversed between two consecutive stops is from equation 5. We can obtain S is equal to 8f by omega square. Also, we know that average velocity between 0 to 2 t time, the equation for that is v dt integration 0 to t and dt integration 0 to 2. So this is the equation. So we have to find out the average velocity between two successive stops, means from 0 to delta t. So we can easily calculate putting the value of v and t as 0 to delta t, and below 0 to t is the delta t. So upon solving this, we will get this average velocities. So hopefully you understood how the problem has been solved. It's basically mathematics. In case of any doubt at any place where you could not understand, please do let me know through your comment. Thank you.